Morning, Eric.
Good morning. It's been a long year of these things.
Hey, we're almost done. Our final exam is next week and we're done. Yay.
Yeah, when summer vacation comes, at least school will be home free. So
Yeah. I'm worried about next fall though. So I hope it's not, I'm a little bit worried it's going to be more of this next fall.
that's like 4 or 5 months away. So I
Yeah,
think we got plenty of time for things to ease up.
I hope so.
I I got I don't I don't think that the cases have been increasing as rapidly as they have been earlier in the months because so many people, I guess, so many people are infected. It's like, yeah, it's like not many. It's not like there's not many more people that can get infected. Although if you think about it, the majority of the people who are infected are spread across states stuff. They're really just the sickness is congregated in places like New York and real big hotspots that are highly congested population.
Yeah.
Yeah,
I'm hoping that maybe the summer with the humidity and the sunshine and stuff, maybe that will take care of the problem, maybe. Fingers crossed.
we've already had days like that.
Not very many though. It's been a cold spring.
I wouldn't say it's cold. Well, I'd say it's a little bit more cooler than usual.
Yeah.
It's never cold during the
Yeah.
spring, but it's just a little bit cooler than usual.
Yeah.
I'm surprised that we've been seeing so many sunny days in the spring. Usually it's very cloudy and rainy, so hey, there's a
Yeah.
bonus. It's just the last of whatever is left of the polar vortex.
Yeah.
Winter is always the season of illness, and summer is a lot better, but it still has illnesses of its own, I guess.
We're going to go ahead and get started here. People are still coming in, but we're going to go ahead and get started. So let me, you probably want to check your email because I shared with you a folder. So it's the most recent thing I shared with you. If you go in your email, you should be able to see that. Anyway, let me kind of share with you my screen. So you can see I kind of have everybody's name here. This little person on there tells you I shared it with you, and I think it gets shared with you through your email. But let me talk about the calendar for today. So what we're going to do is, if you remember the last time we were together on Tuesday, we were kind of looking at Newton's third law. We watched a couple of videos with the water rocket, and we looked at Newton's third law, which is dealing with interaction force pairs. And we saw that those forces were the same size, but they were in opposite directions and they acted on two different things. So they don't cancel, okay? And they're always, it's almost like they're twins. They're always the same type of force. So it could be a tension force, it could be a normal force, but interaction pairs are never two different types of forces. So in other words, the normal and the weight, those are not interaction pairs, okay? We're going to be doing a little bit more of Newton's third law today. Actually, this is the last thing we're doing that's just kind of a review of Newton's third law. And then after that, we're going to talk about the final exam, which for you guys, the final exam, the next time we're getting together, we won't get together on Tuesday. Nope. We're getting together on Wednesday. Okay. That's the next time we get together, and that's you're going to be your final exam. And so some of you are probably wanting to know, well, is there anything I can review? Well, the only two sections we've done this semester have been over motion, like with motion maps and graphs and stuff like that, and the stuff we're doing now, forces. But I do have a packet here, a study packet, and the answers. We'll look at that at the very end, though. So anyway, if you go in your email, there will be a email that says that I shared something with you, and inside that folder, like here's folder, there will be a bunch of Google Draw documents. Okay, let me go back here. And the one I want you to open up first is the one right here that says Newton's third law worksheet number 1A and B. And if you open that up, it kind of looks like this. This thing is constantly in my way. Okay, so I have an example over here of what we're going to do for all of these, but in this example, right below it, it says fist hits wall. That's kind of like the action. The fist is hitting the wall. The reaction would be the wall hits the fist. Now, don't think of action and reaction as like it's not an argument. So a lot of times you think of action as being first and then reaction comes up later. No, that's not the same thing. We're not talking about arguments with people, action, reaction. Nope. We're talking about forces. And these forces actually occur in pairs. And so they're like twins. They happen exactly at the same time. So there is a push force on the wall from the fist. And its twin is a push force. It's the same type of force. It's a push. And instead of being on the wall from the fist, it's on the fist from the wall. So notice how they're equal in size, but they're opposite in direction. So what you're going to do is you're going to be doing A and B. The first thing I'd like you to do is notice over here for the example, it says fist hits wall, then wall hits fist. I want you to come up with the other statement. So head hits ball, you need to figure out what goes in the blank there. And by the way, for drawing, what you do is, or for writing, you just grab this tool up here and you can write whatever you want to in it, right? Okay. And then for the one right next to it, it says windshield hits bug. Well, you need to figure out what's the other statement. Just like fist hits wall, wall hits fist, you need to figure out what the other statement is. On top of that, I'm hoping you can see in the picture part A, there's this arrow. That's a force going up toward the center of the ball. I would like you to draw the other pair. Remember, these occur in pairs. They're twins. I want you to draw the other twin force. Same thing over on the car one. You can see the force on the bug getting smashed. I want you to draw the twin to that force. Okay. So let me stop sharing for a second. Did everybody have a chance to look in their email? Okay. Yep. For the reactions, can you give me a thumbs up if you found the worksheet? Okay. So keep looking. So Ryan, Liam, I haven't got a thumbs up from you yet. Okay, Ryan.
I got it.
Okay. All right. So I have to open up some breakout rooms. So give me a second here. Okay, so let me go ahead and open the breakout rooms. The reason I'm putting you in breakout rooms is that way you can kind of talk to your partners. And if you're like, I don't know what I'm doing, what am I supposed to do? And then you can kind of talk to one another. You can even, I think you should be able to share your screens, I think. So let me open up the rooms. Liam, you should got an invitation to go into breakout room 3. If you didn't, if you go at the very bottom down there next to, there you go. Okay, I'm gonna share my screen with you, and since this is the first one, that way you understand if you did it right, you could kind of check yours. After that, I'm kind of hoping that people will start volunteering, because I think after a while you're like, oh, this is pretty easy, I get this, no problem. So let me share my screen with you. So the first one we'll look at here, let's see if I can make this smaller. The first one we'll look at here is the kid hitting um, the soccer ball. So I did these two forces in different colors. The truth is they should be the same color. That's the same force. They're both push forces. They're twins, so they'd be, of course, the same. So one, though, is the ball on the head. That's the one that's going up toward the right.
How do you do a big arrow like that?
Oh, how did I draw this arrow here?
No, yeah, like the big arrow.
Yeah, the way I did it is I come up here and I pick arrow, and you can make it whatever length you want. And then here you can either make it fatter or you can make it thinner.
Oh,
You can also change where the arrowhead is. Like if you want the arrowhead on the other side, it's kind of cool. Um, and another thing that I kind of think is kind of cool about it is after you draw one arrow, you don't have to draw another one. You could just select it and do. Do you know how to do copy paste? You hit Control C, that copies it, and then Control V, that pastes it in. So that's kind of cool.
okay.
Notice if its head bumps ball, then the reaction is ball bumps head. So the thing I want you to get here is that you can't really touch something without it touching you. I wish I would have known this when I was a kid, because my brother and I always used to sit in the back seat and we'd fight all the time. My little brother would say, "Oh, he's touching me, stop touching me." The truth is, I could have said, "Stop touching me," right? If I touch him, he's touching me. Just maybe it's not the same kind. Anyway. The next example, we've got this push force on the bug from the car, and its twin is in the opposite direction. So the push force is now on the car from the bug. I have a question. If these forces are truly the same size, why is it that the bug gets smushed and the car doesn't get smushed? Can you think of why? The forces are the same size. Why doesn't the car get smushed?
Car has a lot
Because
more
the
mass
force
than
isn't that big.
Well, no, Sophia, the forces are that big. They are the same. It's Eric. Can you say it? You said it. I think Eric said it a second ago. What's the difference?
the car has a lot more mass and weight.
That's right. It has a lot more mass, and so it has more inertia. It's lazier. It wants
Well,
to,
I guess I shouldn't have said weight. Weight is
yeah.
gravity.
It just wants to keep on going. So the forces are the same side. So when you're driving down the road and you hear this big bug smash into your windshield, and you're thinking, oh, okay, there, it has the same force. So whatever that force was, let's say it's 10 newtons on the bug, it's 10 newtons on the car too, but it doesn't have the same effect on the car because the car is so massive. That's why. So if the windshield hits the bug hits the windshield. Okay. All right, the next one we're going to be doing is in your folder. There should be one that says Newton's Law, Worksheet 1, C and E. We just did A and B, so now we're going to do C through E. Okay, so again, I put the example over here so you can see fist hits wall, wall hits fist. That way you can figure out what goes in the blank for each of these. Then I would like you to also draw in the arrows. So let me stop sharing and open up the breakout rooms. Ryan, breakout room number 3. I only had 6 kids show up. I'm not hassling them anymore.
Yeah.
I give up on them.
I don't blame you.
Yeah.
Should be
I'm not hassling them every day to come.
every single day. Exactly. You shouldn't have to.
I need help if that's what it is. That's why I need attendance people.
Right. So that was physics first?
Yeah.
6. 6 out of how many?
About half. It's about half the kids.
Yeah, school needs to go back to normal.
Well, I think especially for these kids. I
They're
mean,
not mature enough and their parents don't make them.
does anybody want to share their screen? Okay. I'll show you what I have then. Okay, so for the first one, I noticed they show this force that's on the ball. So there's a push force on the ball from the bat, but there's also this one in the opposite direction. It's twin, which is also a push force. If this is a push force, then its twin is also a push force. Instead of being on the ball from the bat, this force that's in the opposite direction is on the bat from the ball. They don't cancel because they're in 2 different things. So if the bat hits the ball, the reaction is the ball hits the bat. Okay, the next one I had was, I see this force kind of going into the person's head. That's a push force on the nose from the hand. Well, the reaction would be the nose is touching the hand. So there's a reaction in the opposite direction. It's also a push force, just like this is a push force. And instead of being the nose, on the nose from the hand, this one's on the hand from the nose. So action, reaction. Now again, don't think of them as the reaction happens after the action. That's not true. It's not an argument. This is 2 things that happen exactly the same time. They're twins. They're created at the exact same moment. You can't have one force totally by itself. Okay, then this last one, if the hand is pulling on the flower is pulling on the hand. So here's the action force. There's a pull. Excuse me. Oh, I think I got my order here wrong. Wait a second. Yeah, I got this wrong. Sorry. This is messed up. This needs to be on the flower from the hand. Got that reversed. And this down here is also reversed. This needs to be on the hand from the flower. So you can see the action force here is pulling this direction, and it's on the flower from the hand, and the reactionary force is the flower is pulling on the hand, so it's on the hand from the flower. All right, so the next one we're going to do is, let's see, we've done A through E now. We need to do F and G. And again, I have the example here to help you. And you need to figure out what goes on the blanks and draw your reaction forces in. So let me stop sharing and open up the breakout rooms. Anybody want to share their screen? No?
I didn't get enough done.
Oh, yeah, you want to go ahead and share, Eric?
I didn't get it all done, but I guess I can show you.
Yeah, maybe share what you have anyway, okay? Make it more,
It looks like it's disabled.
make it more interesting.
It says it's disabled.
Oh, gosh darn it, that happened the other day. Okay, how do I do that? Oh, I know what to do. I'm gonna make you, Eric, you are gonna be the host. There you go. You're the host. Now you get to do it.
Mr. Linfesti,
Yeah,
if you go to your participants
yeah,
and you go to like the like you hover over them and it says more,
yeah.
like you can like fix all that and like
Oh,
enable
thank you
that.
very much. Thank you very much, Alita. I didn't know that. I think it just changed the other day. I don't know why it changed, but
Yeah.
thank you.
Actually, it updated. There was an update.
It was an update. I hate these updates. I can't keep up with them. I'm too old. I'll go in and fix that. All right. Thank you very much, Alita, for letting me know that. All right, Eric. So you have the
This
forces. Yeah, you said. Okay, so athlete pushes bar upward, left sides of bar pushes left arm down. Nice. And right side of bar pushes right arm down. Perfect. Or if you just want to, you could have just combined them into one and just say the bar pushes the athlete down. You could do that too. Nice. Excellent. So, Eric, if you can stop sharing, and I will see if I can fix what Alita said during the next one, I think. Okay, and let me reclaim those. All right, so let me share my screen to show you the other part then. So I went ahead and drew them in red so it's a little easier to see. They're not different forces though. They're the same. Each one of these in the balloon is a twin. So if the compressed air pushes balloon surface outward, balloon surface pushes compressed air inward. I also didn't label the forces like I did over here. I didn't have enough time, but each one of those would have been a push force, and it would have been the air is being pushed by the balloon, I guess. So there's a push force on the air from the balloon. That's what the red arrows are. All right, let me stop sharing. And I want, actually, wait a second, let me keep sharing. I gotta share something else. All right, let me see here. The next ones we're gonna be doing, okay, so we just took care of F and G. We still have to get through the rest of these. So I think we're gonna divide and conquer some of these, okay, to make things go a little bit faster. So let me stop sharing again. And okay, so we've done all of number 1. Now we're getting ready to do 2 onward. So number 2, I would like you to do this one. Oh, you guys can't see that. All right, so how do I, all right, hold on a second. I want to make sure that you guys know which one I'm assigning to each of you. All right, so Eric, can I have you do number 2, which looks like this? Okay, so I'll have you work on number 2. And let's see, Alita, can I have you work on number 3 that looks like this? This is actually not that hard. It's kind of like it's almost like a multiple choice. In fact, how about Alita, Sophia, why don't you guys work on that one, okay? And then let's see here. So how about Haley, can you work on this one, 3D? Again, it's kind of like a multiple choice almost thing. It's where you circle the answer. Okay, and who am I skipping here? I can't see everybody. Ah, there we go. Okay, Ryan, can I have you work on, let's see, this next one here? It's 3E and F. Again, it's kind of like multiple choice. You circle the answer, okay? And then Liam, can I have you work on this next one here? 3G and H. Again, it's kind of like multiple choice. You kind of circle the answer, okay? And I think I've covered everybody, okay? So let me stop sharing.
Wait, which one am I working on again?
I think you're number 2.
Number 2, okay.
Okay, so let me go ahead and open up the breakout rooms.
So that's a total of 6 pairs.
So Eric, when I call people back, yours is probably taking the longest. So when I call people back, you just keep on working on it, okay? I mean, you'll come back
Alright.
too, but you can keep on working as we're going over the other people's answers, because all they have to do is circle the right answer, whereas you have to draw arrows and stuff. It takes longer, okay?
Yeah.
Okay. Oops, I clicked something.
And you can copy and paste these. Should they all be the same length? What do you think?
So Lita, I'm looking over here on the participants, and I click the more, but I don't see what you're saying. I see make host, I see allow record, rename, put in waiting room, and remove, but I don't see.
Oh, well, last time I did it, it was like you like had the option to like change their settings. Or
Oh, I wonder if that's like on the main page. I bet I have to do that on the main page because I don't see it here. Yeah. Okay. Sorry. I'm kind of spacing here. I'm trying to figure out how to. It's not a big deal. I could just make each one of you hosts. It worked before. Anyway, I'm going to give Eric a little bit more time because he had to actually draw arrows in, so it took a little bit longer to do his. So we're actually going to do number 3, that first one, that part A. So Sophia or Alita, do you guys, which one of you would like to share yours, and I'll make you the host, the hostess with the mostest.
I could.
Okay, so Sophia, you are now hostess with the mostest. You can go ahead and share. All right, so for the first part there, so what's happening if you weren't working on this problem, Nellie Newton is holding this apple in her hand. It weighs 1 Newton. And it says to say the weight of an apple is 1 Newton is to say that a downward gravitational force of 1 Newton is applied on the apple by, so Sophia, you're saying that her hand causes gravity? Sophia?
I'm at Earth.
Okay, all right. So that first circle there, could you move that first circle up to Earth? Yeah, okay. So then Nellie's hand supports the apple with a normal force. So you can see in the force diagram there, there's a normal force that's upward. They labeled with an N, which acts in a direction opposite to W. We can say that N equals W. Okay, so if you look at N, it has the same length as W. Is it in the same direction, Sophia?
Yeah. Wait, no.
All right, okay, so wait a second. Sophia, are you looking at the cartoon where N is up and W is down?
Yeah.
Okay, so it's not in the same direction. So I don't think you could say it equals. It has the same size, but it's not in the same direction. So it's not equal. So it's just the same size. Yeah. Okay, since the apple's at rest, the net force on the apple is 0. That's true because those forces balance out and they cancel. Okay. All right, thank you very much. Give her a hand down there. Yay. Where's my reactions at? Yay. Awesome. Okay. And now let's see. For the next one, who had the next one? Oh, that was Haley. So let me see if I need to reclaim the host. And then Haley, you are now the hostess with the mostest. So if you can share your screen with us. All right, so let's see. Okay. So since N is equal and opposite to W, so everybody stop and look at the force diagram. See how N's the same size, but it's in opposite direction. And Haley's saying that we can say that N and W comprise an interaction force pair. That means they're twins. That means they're exactly the same except they're in opposite directions. So look at the letters, N and W. Are those the same type of force? Anybody? Are those the same type of force?
No.
No, I mean, the N is a normal force and W is a gravity force. So Haley, can you move that first circle down from can to cannot? It's true they are equal and opposite, but they are not action-reaction forces, because action-reaction forces are like twins. They look exactly the same. That would mean you'd have two weight forces, or two normal forces, or two tension forces. Okay, then she says, the reason is because interaction force pairs always act on different objects. Perfect. Yeah, they act on different objects. And you can see here, both of the forces act on the same object, on the apple. So yeah, so these are not interaction force pairs. Good. So give her a hand at the bottom. Yay. Yay. Oops, it went away. There it is. Okay, the next one we're gonna do, I need to look, I forget which one we're doing now. Okay, so that was D. Now we're doing 3E, F. Okay, I forget who had that one. I think was that Ryan? Yeah, Ryan. Okay, so Ryan, you are now, let's see if I can find you here. You are now the hostess with the mostest. You should be able to share your screen now at the bottom. Okay, so according to the rule, if action is A acting on B, then reaction is B acting on A. If we say action is Earth pulling down on Apple, the reaction is, now wait a second. So Ryan, look at the, in quotes, they have action is A acting on B and reaction is B acting on A. Notice all they do is switch the B and A. So the first one is A acting on B. The second one is B acting on A. So it says if the Earth is pulling down on the apple, all we do is switch the words Earth and apple. So Earth is pulling down on apple. Yeah, it's going to be apple pulling up on the Earth. So this is a question not for Ryan. This is actually for everybody. So think about it for a second and then maybe tell me your answer. Why is it that the Earth does, excuse me, the apple does pull up on the Earth? Why is it we don't see the Earth move upward? Why do you think? Anybody?
It's too big.
It's too big. Yes, it has so much mass. It has so much inertia, right? I mean, it does move up, and you might be going, well, Mr. Linfesti, you say it does this, but I don't see it. I don't know if I believe that. Can you give me some proof? And your proof is the following. There is something that's pretty massive that falls towards the Earth. It doesn't fall into it. It falls towards the Earth, and the Earth falls towards it a little bit. And if you've ever been to the ocean, you've seen the tides. The tides are caused by the moon. It's because the water's getting pulled a little bit towards the moon. So that's your proof that the Earth does move a little bit towards other objects. It's just that the mass of the Earth is so small, or excuse me, is so big compared to the mass of the apple, you don't notice the effects. But when you compare the mass of the Earth and the moon, yes, the Earth is more massive than the moon, but the moon is pretty massive, and that's why it has a little bit of an effect on the Earth that you can see anyway.
Actually, that's actually the Earth moving closer to the moon is what causes the supermoon phenomenon.
That's right. Yeah.
Yeah, it's just that the moon has a circular orbit around the Earth, but it doesn't stay the same distance from the Earth at all times.
That's
It's
right.
sort of swinging around the Earth.
Yeah, that's right. Yep.
And when it swings closer, that's when you get a supermoon.
Yep.
When it swings farther away, the moon actually looks smaller in the sky than it normally does.
That's right. Then for the second part F, to repeat for emphasis, we see that N and W are equal and opposite to each other. but do not comprise interaction force pairs. That's exactly right. The only way they're interaction force pairs if they're twins, if they look exactly the same. So if it's two W forces or two N forces, right? Absolutely. Give Ryan a hand. Yay, everybody. Ryan a hand. Yay. And then Ryan, stop sharing. Yeah. Yay. Okay. Nice. Okay. Then the next one, I think this was Liam. Is that right? I think so. So I'm going to go ahead and make Liam, if I, oh, I have to reclaim the host first. Liam's going to be the hostess with the mostess. There you go. And then Liam at the bottom, there's a little green share. And then when a pop-up comes up, hit the blue in the lower right, that blue button there that says share. Liam, do you know where the share is? Ah. Okay, let's see. Another pair of forces, N, and the downward force of the apple against Nellie's hand, which is not shown. This force pair is an interaction force pair. That's right. So it shows the N there, but there's another N, another normal force on her hand. So that normal that you can see is on the apple. Well, there's another normal that they're not showing on the hand that's downward. That is an interaction force pair. Nice job, Liam. That was a hard question. Suppose now that Nellie pushes upward on the apple with a force of 2 newtons. Okay, so the weight of the apple is 1 newton. And now she's going to start pushing upward at 2 newtons. I'm hoping you can see that, hey, the apple's going to start to accelerate because it's not balanced anymore. Nice, good job. And compared to W, the normal, now in this case, Liam, as soon as she starts pushing upward with a force of 2 newtons, it won't be the same. It's actually going to be twice as big. So make that circle go down and move that circle to twice as big. Okay, nice. Okay. All right, give Liam a hand there. So yay. Awesome. That was hard. He had like 2 or 3 hard ones there. All right, so then Liam, there should be like a red stop sharing kind of a thing somewhere. There you go. Let me reclaim the host. And was that everybody? Oh, Eric, I have to go back to you. Did you have enough time?
Yes, I think so. Just
For most
give
of
me
it anyway?
give me a second. I'm writing the last one.
Well, how about I share my screen and do the very last one, then you keep on working.
Yeah. Good.
Okay, so I want to share I then. So, okay, after being pushed upward, the apple then leaves her hand. So in other words, she is kind of like getting ready to throw this apple. So she's pushing upward and the apple leaves her hand. She's throwing it upward. After it leaves her hand, the normal then disappears because she's not supporting it anymore. So that means it goes to 0. And the net force, well, just because the normal goes to 0 doesn't mean the weight goes away. So the force diagram would still show a weight force on the apple. And so the net force would just simply be the weight. That's it. And there's a little cartoon there if you're into that kind of thing. So let me stop
I got
sharing.
it.
Cool.
You
And then I'm
can
going to
share.
make Eric the hostess with the mostess. It's all yours now.
All right. So let me show you what I did.
There you go.
So because there's not enough space to write all that, what I did down here was I just kind of made a chain of all the forces acting on one another.
Okay. When you have that little greater than symbol, do you mean greater than, or are you just saying one force then causes the next force and so on?
I'm just using that as an arrow just to point into the next one. So don't see that as a greater than symbol. Just see it as a little arrow pointing to which force acts on the.
So you have a pull force on the rope from the man, and then that has a twin of pull force on the man from the rope, right? Is that what that is?
Yep. And then there's the pull force of the rope from the monkey, and then there's a pull, and there's a tension force of the monkey and the rope. I think that's a tension.
Okay.
Because it's a rope.
Okay.
And then there's a pull force of the rope of the monkey over here.
Okay.
And then there's another one of those. This is a pull force. Actually, this is a force of tension on the rope from the scale.
Okay.
This one's on the scale now. And then this is a force of pull on the scale on the rope. and then there's the force of tension on the tree from the rope, and there's a force of pull from the rope on the tree.
Nice.
You know,
Excellent. Perfect. Can we give Eric a hand? Nice. Yay. Yay. All right. And if you could stop sharing anytime. Okay, and let me show mine as well. I kind of drew it and read the arrows. I didn't go into detail that Eric did. That was nice. So I want to kind of share mine as well. That way you can just kind of see the arrows. So I drew the exact same ones that Eric had. I just drew them as arrows. So here's all the way over to the left. There's one set of twins. Here's another set of twins. Here's another set of twins. Here's another set of twins on the scale. On the other side of the scale, here's the other set of twins. And then over here is a set of twins. So I had 6 of them. All right, well, we're done with that worksheet. We're actually done studying for all the Newton's third law stuff. There won't be a attendance quiz today because you guys, if I'm kind of encouraging you to study for the final exam, which is next Wednesday. Oh, you need to make a note of this right now on your calendar because I'm worried that some of you will miss the Zoom session. We normally have Zoom sessions on Tuesdays and Thursdays, and they're usually at 9:20. Well, if you come on Tuesday, or actually if you come on Tuesday, nobody's going to be here, first of all. And then if you come on Thursday, you've missed the final exam. That's not good. That's bad. Also, the time is different. It's not at 9:20, it's at 7:45. So please put on your calendar right now, 7:45 next Wednesday is the final exam. So what I would like you to do, though, is instead of doing an attendance quiz, is between now and probably over the weekend or something, is start working on the study packet. It's not for a grade. I'm just telling you you should do it to get ready for the final. And let me open it up so you can see it. So just to refresh your memory, stuff we've done this semester is like motion maps and graphs and figuring out when things speed up, slow down. Probably if you look through all the, well, of course, papers are in school, but you might have some of these papers, I'm not sure. Then we did stuff with forces where you drew force diagrams, system schemas, that kind of stuff. And there was even you had to do some calculations with triangles. And if you're like, oh, I don't know if I remember all that stuff, I need to have the answers. Well, after you try it, after you try them first, the answers right here. I don't want to open them up because I don't want you to see the answers yet, but because I want you to try them first and then you can look at the answers. All right, so let me stop sharing. I do need to get a real quick picture for attendance purposes, mostly because I need to contact the people who are not here so they make sure they attend on the final exam day. So let me quickly get a picture here. All right, that should be good enough then. Any questions before you leave?
Nope.
All right, then see you on Wednesday. Don't forget. Bye. Later.
You have a good day.
You too. Bye.
Bye.
Dave, I actually got the exam made, but I still have to do the voice things. I talked to Olivia. It's not actually text-to-speech thing, or if there is, it must be a different teacher. I don't know how to do it, but there's something where I can do a recording for each question where I'm reading it to them.
Oh, okay.
I have to do that. It's gonna take me a while. So, but I plan to have that done over the weekend, if not before then, and so that should make things go a lot smoother. Then I don't think there will be any problems other than
it should be covered then.
yeah.
I didn't realize that you had to do that.
Yeah, when I talked to Olivia, there is something in there that you can, I can even do a video where it sees my face, but you could just do a sound, and that's what she does. And evidently they kind of divide and conquer because there's so many biology teachers. They divide and conquer where one teacher does one test, another one does another test.
Yeah.
And so on. So, but I mean, that was definitely one fear of mine. So it's nice to know that we're going to meet that IEP thing. I was a little bit worried about that. So that's not going to be an issue. I did talk to them about how to make it so kids that have a longer IEP and have to do it over multiple days, how they done it. And I was right in thinking, yeah, go ahead and divide up the test and just give different links. And so
Yeah.
I don't think that'll be a problem at all. So I don't anticipate any problems whatsoever. And I might have to share those access codes with you kind of last minute. So
Okay.
I guess maybe look at your email, maybe
Yeah,
on
just throw it in
Sunday
an
or
email.
Monday. Yeah. Okay.
So
All
I
right.
probably have some that will want to just get it all done at once. So
Yeah, oh yeah, I can, oh, so, okay, I didn't even think about that, so, well, that shouldn't be an issue. If I make the time, any time in this week or whatever,
mhm.
now they'll both have, let's say I divide it into two, like, for instance, Josh Brown, he gets double time.
Mhm.
So if I divide it up into two tests, I don't see that's an issue then, right? If they
No,
have the
yeah.
code and everything.
Right. Yeah. You can just do
Okay.
back-to-back stuff.
Okay, all right, that works then.
And hopefully they'll just all get it finished up.
Yeah,
I never
that,
really have problems with them.
yeah, that's
not
what I
getting
think
finished,
too.
so.
Yeah. All right. Well, I think we're set. I think.
We should be good.
Yep.
Hopefully it
And-
goes smooth.
Yep. I'm gonna send Google Voice to the people who didn't come, which is quite a few,
Yeah.
making sure they understand when the final is. And for the ones I'm not getting any contact through Google Voice, I'm actually going to call them, make sure their parents understand.
Yeah.
Okay. All right.
Let me know. Yep. Hey,
Okay.
have a good weekend.
You too. See ya.
Thanks. Bye.
Bye.